You have n boxes. You were given a binary string boxes of length n, where boxes I is 0 if the ith box is empty, and 1 if it contains one ball. In one operation, you can move one ball from a box to an adjacent box. Box I is adjacent to box j if the distance between the two boxes is only 1. Note that after doing so, there may be more than one ball in some boxes. Return an array answer of size n, where the answer I is the minimum number of operations needed to move all the balls to the ith box. Each answer I is calculated considering the initial state of the boxes. So all this really means is that we're given a binary string. Each 0 represents an empty box, and each 1 represents a box with a ball. And we want to move each one of these balls to every single box, resetting its position every time. So by the end of this, we should have an array where all the balls have been moved to this box, this box, this box, all of them together. So for example, let me just mark this down. This is going to be box 0, 1, 2, 3, 4, 5. To get from box 2 to box 0, to move this ball here, it's going to take 2 operations. 4 to 0, from here to here, take 4 operations. And 5 to 0 is just going to take 5 operations. So adding these all together is going to give us 11. And then we want to do the same thing for this box. So from 2 to 1, it's just going to be 1. From 4 to 1 is going to be 3. And from 5 to 1 is going to be 4. So all this together is going to be 8. And we could do this on and on for all of these values. And the way that I'm doing it is going to be an O of n squared solution. This isn't our optimal solution, and we're going to do another one next. But the brute force, what we've just done, is pretty straightforward. We're just going to go to our box and then look from left to right where the balls are, and then add them to our current index, and then just return this array. And again, this is our n squared solution. This isn't the one that we're going to be finishing with. The reason why I'm mentioning this n squared solution, though, is that I want you to try to get an idea of what our O of n solution is going to be, our O of n. So this is a good first attempt. Why? Because it shows us the basics of what this algorithm is going to be. But you'll notice that we're doing a lot of redundant work. Every time we go to a new box, we have to re-look up all of our ones. We have to see where all of the balls are. Instead, what we're going to do, we have to try to remember where the balls are. If we can remember where the balls are, we might be able to go from a n squared solution to our O of n solution, something where we don't have to look for the balls every time. So let's say instead, I scan through our array in the beginning. I look through all of these elements to begin with, and I say, all right, I know that there's 3 balls to begin with, and they are to the right of where I currently am. If this is the case, and I know that the first sum is 11, and then I move to my next box. I'm going to just get all these boxes here, 3, 4. Okay, there we go. So now if I move from here to here, and I know that I haven't seen any balls left, what is this answer going to be? It's going to be an 8. And how do I know that? It's because if I move from here to here, then I know that I'm getting closer to all of the balls. I'm subtracting a distance of 1 from all of the balls already. I don't necessarily have to know where all of them are. All I have to know is that my previous answer was 11. And as I move to the right, I remove a distance of 1 from all the balls. And I know that because I have 3 balls, I have to remove a value of 3 from 11, and that's how I get my 8. And I mean, you can see this in action right here. This was our original values, and as we moved over, we're just decrementing 1 from each of those distances, and that's how we get our 8. And I mean, we could even continue this trend as well to get our next answer. So this distance from 4 to 2 is just 2. The distance between itself and itself is just obviously 0. And then we have that distance of 3. So this is 3. This would be 5. And if we look back at our answer currently, that 5 is the correct answer. But this is kind of besides the point. Going back to our algorithm that we're working on, we're going to do the same thing again. We're going to decrement 3 again to get our 5. And why is that? Because we move from here to here, again, we're going to be removing a distance of 1 from all the balls, even if there is a ball already in that box. Things are going to change though once we get to this box, because what happens here? Now we have a ball to the left of us. So instead of having 3 balls to the right, we're just going to say, now we're going to say we have 2 balls to the right, 1 balls to the left. And as we travel to the right, our distance away from the left is going to increase. So what does that mean? Pretty much our formula that we're going to be coming down to is our current value, or really whatever is our previous value, minus the number of balls to the right, number of balls right, plus the number of balls to the left, balls to left. So now that we have this formula, let's actually use it. So when we're here, we know we have 1 ball to the left, 2 balls to the right. We're using our previous value. So 5 plus 1 is 6, minus 2 is 4. Move over. Because we have a 1 here, it's still going to count as a ball to the right. So we're going to do the same formula again. 4 plus 1 minus 2 is 3. We move over. We have to change this now to a 2 and this to a 1. So moving over again, we have 3 plus 2 minus 1 equals 4. And if we look back at our example solution, this is exactly what we get. All right, so let's start coding this up. And again, all we need to begin with is just the total number of balls to the right of us, as well as our first sum. So let's do that. Let's start with some sum total and the balls to the right. I'm calling it right and equal balls just because when we land on a space that has a ball already in it, we're still going to decrement. Let's iterate over all the values in the boxes. And if we encounter a 1 in one of those boxes, we're just going to add I to the start total. And this is just because as we travel from left to right, the distance between our first box, our box 0, and whatever box that we find a ball in, just coincidentally is going to be I. So we just keep adding it to this start total. And this also add 1 to the number of balls to the right of us. Now our current answer is just going to be that start total. We're just going to append it right to the front. We're going to set our current value to our start total. This is the thing that we're going to decrement from. And then obviously left balls are just left balls. We haven't seen any yet. Now you probably could use a for loop for this, but I'm going to use a while true just because it gives me a little bit more control over the index. So what I'm going to do first is I'm going to say something like if boxes I equals 1. And the reason why I'm starting at 0 and then doing this first instead of incrementing is because I want to change the value of the balls before we move to our next position. Now I'm ready to say I plus equals 1 because everything up until this point, we've pretty much done the answer for the first box here. And just because we're using a while true and we need to make sure that we take care of all of our breaks and everything, I'm just going to say greater than or equal to length of the boxes, we break out. We're just going to use our equation that we derived and just append our answer. And then we're just going to return our answer. So let's see if this runs. Let's see if this submits. And there we go. So all in all, this wasn't that bad of a problem. So long as you were able to do the brute force solution and then just realize that you're doing redundant work, you can find a more optimal solution, which is a pretty good approach for most LeetCode problems. Like, subscribe, a link to the code will be in the description. Join our Discord for some extra help, problem suggestions, and announcements, and I'll see you in the next one.